Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel. That channel is specially created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. Today's class promises to be very interesting and insightful as well. I wish to appreciate your continued support and subscription. Please feel free to share, like, subscribe, and most importantly, tune in your button so that you'll be the first to know when our next video shall be dropped. Today we are looking at a very important topic in mathematics, which is more or less the further math genre of mathematics, and that is probability distribution. Probability distribution is quite different in nature from mere elementary probability. So what exactly is probability distribution? To better understand what probability distribution is, we need to understand the concept of random variables. So random variables are assigning of values to experimental outcomes. So what then is probability distribution? Simply put, probability distribution is a collection of all possible outcomes of an experience or of an experiment along with their corresponding probabilities. So probability distribution can be likened to the frequency table you have in elementary statistics. So for example, in a frequency table, let's start a comparison. We have data sets and their corresponding frequencies. Say you have 2, 3, 4, and 5 and data sets. And the frequency are maybe 4, 1, 3, and 2. So that means the data 2 appeared 4 times, data 3 appeared once, data 4 appeared 3 times, while data 5 appeared twice. This is frequency table. However, probability distribution, on the other hand, is simply collection of random variables and their respective probabilities of occurrence. So if you say, for example, now the random variable, let's say x1, we have probability 1, x2 probability 2, and x3 probability 3. So in lieu of frequency for the respective data, we have probability for the respective random variables. That's exactly is what probability distribution is. Now, probability distributions have basically 2 categories. We have either the discrete or the continuous. And the discrete, a lot of examples abound. We have, for example, the Bernoulli distribution, we have the binomial distribution, and we have the Poisson distribution. These are examples of discrete distributions. We have Bernoulli, we have binomial. Of course, they are not limited to this. And we have the Poisson. These are examples of discrete, and many more, of course. But for the purpose of our videos, we shall be shooting to just the binomial and the Poisson in later videos. On the other hand, for continuous, which is actually beyond this level of this class, we have a lot of examples. The most popular of them being the normal or Gaussian distribution. So now, after having explained thus far the basic concept of probability distribution, let's now kickstart with the very basic one which we are learning, and that's the binomial distribution. So what exactly is the binomial distribution as our first classic example of discrete random variables or probability distribution? So there are some properties or conditions that must be met before you can identify a distribution as binomial. As a matter of fact, there are 4. So the first property to be met is that of n fixed trials. There are n fixed number of trials. So there must be a definitive fixed number of trials of an experiment to start with. Now, and each trial has only 2 possible outcomes. two possible outcomes, and we call them success or failure. Just two possible outcomes. The probability of success is the same for each trial, and it's denoted by P. Then lastly, the trials are independent. So if all these four conditions are met, then a particular random variable is described as having the binomial distribution. I go over again. The first condition is that there are n fifth number of trials in an experiment. Then two, what that means is that it's not indefinite. The number of trials are not unlimited. It's fixed. Now, each trial now has only two possible outcomes. So each experiment in the trial is either a success or a failure, a 0 or a 1. No three options there. And probability of success in each case is the same all through. For all the numbers n, each has the same probability of success and failure as the case might be. And lastly, the trials are independent. That means the outcome of one trial doesn't have any effect on the other outcome. So these four properties, if met in a particular random variable, we describe such a random variable as having the binomial distribution. Then we're looking at the formula for computing the probability of binomial distribution. So we say the probability of an event x for a binomial distribution is given as probability of an event x equals to n combination x p raised to power x 1 minus p raised to power n minus x, x running from 0, 1 up to n. So this basically is the probability of an event x occurring in the binomial. So you have n being the number of fixed trials, x is the probability of the events we are seeking, and p is on that case, it's very from capital P. P is the probability of success in each of the experiments. And 1 minus p will give the probability of failure. And x will range from 0 to n. This general formula for computing the probability of an event x for a binomial distribution. And this alpha we can go today on the introductory aspect of the topic, probability distribution, and with specific interest in the binomial distribution, which we are going to go in depth into the next video. So I urge you to please stay tuned, subscribe, and tune on your bells to be first to know when we drop a video. And the next topic, binomial distribution proper. Thank you.